Hi everyone, thank you for listening to my presentation. This is the unintended consequences of marine shipping. Marine shipping is an effective way to move cargo anywhere in the world. However, there are some negative impacts that can come from this. These include emissions, noise pollution, and the potential to transport invasive species. All of these have some pretty serious negative impacts. However, things are being done and there are regulations in place to try and lessen these impacts, and which we'll go into in this presentation. So just some general information to get started. Marine shipping is currently responsible for moving approximately 80% of the world's goods, and this is expected to grow as demand for shipping increases. Marine shipping is one of the most efficient ways to move large quantities of cargo. As you can see in the graphic in the bottom right corner, this shows the distance 1 ton of cargo can travel on 1 liter of fuel. So as you can see, the ship is by far the most effective. And while there are definite disadvantages to marine shipping, there are a lot of regulations in place that try and protect the marine ecosystems and lessen the byproducts of the marine shipping industry. So to jump in with air pollution, CO2, NOx, and SOx are the 3 main gases produced by the shipping industry. In 2012, the marine shipping industry, I should say, contributed to 2.2% of the world's total CO2 emissions. As kind of a reference point, the same year Canada was responsible for only 1.6%. And also in 2012, marine shipping was responsible for 15% of the NOx emissions and 13% of the SOx emissions. Currently, if more regulation is not put in place, emissions are expected to increase anywhere from 20 to 120% by 2050, depending on how much the demand for shipping increases. In 2013, emissions were estimated to have reached 1.6 million tons of sulfur dioxide and 3 million tons of nitrogen oxide. And this is just from the Baltic Sea, the North Sea, the northeastern part of the Atlantic, the Mediterranean Sea, and the Black Sea. Kind of continuing on the idea of its current growth, these emissions are expected to at least reach, if not surpass, the land-based shipping method, or the emissions from all of the land-based shipping methods in the EU. Not only do these emissions contribute to the greenhouse gas effect, they also can present some serious health hazards. The NOx and SOx become sulfate and nitrate aerosol particles once they're released into the air due to chemical reactions. These particles are small enough to be breathed in, and when they are, they can cause inflammation in the body. This can lead to heart and lung failure, which in serious cases can cause death. It's estimated that in the EU, 50,000 deaths were a result of breathing in these particles, and the cost to society was estimated to be about 58 billion euros. So just kind of a rundown of some of the policy in place and the solutions that are being used to try and combat this. The International Maritime Organization, or the IMO, began a strategy in April of 2018 to reduce the annual emissions of marine shipping by up to 50% by 2050, and this is 50% of the levels they were at in 2008. Tier 3 of some of the IMO regulation is requiring up to 80% reductions in NOx emissions for all ships built after 2016. And MARPOL Annex, which we'll go into MARPOL a little bit later in the presentation, but these limits the NOx emissions from marine diesel engines with a power output of more than 130 kilowatts. These standards apply to both main propulsion and auxiliary engines and require engines to be operated in conformance with the Annex and NOx emission limits. In addition, they put limits on sulfur content and marine fuels. And kind of to break down why these solutions, or why these regulations are helpful and how they're going to work. By lowering the sulfur in fuels, we can reduce CO2 emissions by about 96%. In addition, applying selective catalytic reduction technology we can lower ships' NOx emissions anywhere from 80 to 95%. IMO regulation put in place in 2008 with the goal of regulating emissions has been estimated to save about 26,000 lives in the EU per year, kind of going back to the deaths in the previous slide. More regulations are trying to be put into place requiring ships to burn or scrub their exhaust to emit no more than 0.1% sulfur. And currently 983 ships being used have scrubbers. In addition, we can add water, use recirculated exhaust gas, cool water tempers, or LNG, or use methanol as fuel. All of this can lower NOx emissions anywhere from 90 to 100%. So moving on to noise pollution, the main pollution caused by noise from large ships is called acoustic masking. This is noise created by large ships and other vessels that interfere with the daily lives of marine life. This interference can be in their ability to communicate with each other, how they detect other things in the water, or how they recognize or understand sounds of interest. Another way this is measured is through cumulative sound exposure levels. This is the total amount of sound waves and frequencies that marine life is exposed to around shipping channels or places where large ships are moving. And ships can generate anywhere from 5 to 1,000 hertz, which is a pretty broad range. And as you can see in the graphic, this overlaps quite a few marine species. This includes baleen whales, fish, seals and sea lions, and some dolphins and toothed whales. So what generates all of this noise? Largely it's going to be the propeller, which is what spins in the water to move the ship. However, the main and auxiliary engines, electric motors, or just the water flowing over the hull or anything else in the water can also generate the sound. And just to kind of break down how some more specific species are affected, humpback whales have been shown to present quite a few behaviors, but this can include stopping vocalizations when ships are within 1,400 meters. Narwhals have been shown to change their movement patterns. They'll often become still and sink. Dolphins have a wide variety of reactions, but a lot have been seen to spend more time traveling and less time resting when they're exposed to increased sound from ships. And one that hits particularly close to home because we have these whales off the coast where I live in Northeast Florida, and unfortunately at the start of this year we had 2 whale strikes, one of which was fatal. But North Atlantic right whales aren't seen to really change their behavior when they're around large ships, which is concerning because scientists think that this might be why they have so many ship strikes, which is a huge detriment to their survival right now. However, it's also believed that their stress levels increase when they're exposed to more sound from these ships, and this has been determined by reviewing fecal samples. So what's being done about this, or what can we do about this? Scientists have found that traveling slower, which could be 13 knots as opposed to 20 knots, generates far less noise, so much less that 2 ships traveling at 13 knots are quieter or produce less CESO levels than 1 ship moving at 20 knots. We could also synchronize ships so that while there might be more noise at one time, there are quiet periods where there is not a large presence of shipping noise in certain areas. In addition, the IMO has released guidelines for the reduction of underwater radiated noise, or URN, which is really helpful to spread information, though this isn't mandatory to follow. And moving on to the final topic, invasive species. I personally thought this one was the most interesting. Invasive species are considered to be one of the 4 biggest threats to marine ecosystems. These species are primarily introduced and moved around through ship's ballast, which I'll kind of explain in the next slide. This is not a new problem. As early as 1750, ships could carry up to 120 species in the ballast. And as ballasts have become more efficient over time, at any given point, they could be carrying anywhere or anything around 10,000 species. And as shipping increases, the number of species is also expected to increase. Climate change also has a role in this, as warmer seasons are now starting to become a little longer and colder seasons could be much more mild, meaning that species that previously would have died upon reaching some environments now have a greater chance of survival and a greater chance of altering those ecosystems. So I mentioned ballast. If you're unfamiliar, large cargo ships don't do great being empty. So when there is no cargo, they're filled with ballast tanks. They have ballast tanks kind of in the bottom of the ship, and those are filled with water. This kind of creates stability in the ship and allows for the rudder and propeller to work properly. However, when the ship is loaded back up with cargo, these tanks are drained, and when they're filled and drained, sediments are stirred up, and this allows microorganisms to enter the ballast, and at times they can live in the ballast depending on the species, for the entire journey, wherever they're going. So, say a ship left Europe and had some zebra mussels in the ballast and then unloaded, say in Boston, those zebra mussels would now be in the port that they unloaded if they survived, and they can wreak havoc, which we'll talk about in this slide. Zebra mussels arrived exactly how I described. A freighter from Europe brought them over, and in North America they have practically no predators and have driven out most of the native mussel species. They at this point have infested more than 40% of U.S. inland waters, and upwards of $1 billion have been spent trying to contain this invasion, which is extremely costly and detrimental to not only the marine coastal ecosystems, but also industry. Another example of this is Scandinavia. The marine environments there have been greatly affected by three main species. These are the comb jellyfish, the round goby, and the Chinese mitten crabs. All used ballast water to reach Scandinavia, and all have a serious impact on the environment and the industry. The comb jellyfish originated in North America, and they eat the same food as many as the fish harvested for industry in Scandinavia, as well as the fish eggs and larvae. And round gobies and Chinese mitten crabs have been extremely competitive for native species and have spread widely, which puts additional strain on the ecosystems. So considering what a large threat these are the regulations in place to try and limit invasive species. The table on the right shows kind of a list of documents and regulations in place, though not all of these are specific to marine ecosystems and marine transport of invasive species. So one of these was the Law of Sea Convention, in an article in 196. Ships should take all measures necessary to prevent, reduce, and control the pollution from marine environments resulting from the use of technologies under their jurisdiction or control, or the intentional or accidental introduction of species, alien or new, to a particular part of the marine environment, which may cause significant harm. And the CBD protocols basically do the same thing and limit, or attempt to limit, the amount of species that can be transported from one area to another. In addition, as of 2005, 122 nations had ratified a document called MARPOL. This document and kind of treaty solely works to try and limit the negative impacts from marine shipping, including invasive species. And in addition, the International Convention for the Control and Management of Ships' Ballast Water and Sediments requires all vessels over 400 tons to have some sort of sanitation or cleaning process in place to try and limit the species that can survive in the ballast and lead to pollution. So that's the end of my presentation. I thoroughly hope everyone enjoyed, and I really look forward to seeing your comments in the discussion post. Thank you so much.